We're going to talk about empirical and molecular formulas today. These are two things that are pretty easy to do. We're going to do a paper pencil lab with it tomorrow. And then next week, you're going to do it with magnesium with a lab report. All right, so we're going to do two different kind of labs with this topic. First of all, what is an empirical formula? Well, it's often referred to as the simplest, let me get that I out of there, the simplest formula because it is a formula in lowest terms, meaning it cannot be reduced. Now, grab some more while y'all write that. Y'all caught up? So, as a way to illustrate this, thinking about something that we would have worked on last week or something similar to what you saw in the test. If you had something like C2O4, what would you have done to C2O4 if you had that on the test? That's right. You'd have made it CO2. All right. This we're going to talk about after a while. This we will call the molecular formula. And this is going to be called the empirical formula. Okay, so that's molecular, that's empirical. The empirical formula, again, is the one that's in lowest terms. It cannot be reduced. So when you look at the subscripts on CO2, what subscripts do we have? We have a 1 and a 2, right? So can you reduce a 1 and a 2 any further? No. Now, things that sometimes confuse students would be something like this one. So when you look at Na2SO4, can Na2SO4 be reduced? All right. Some people say no, which is correct, and some people look at it and say yes. The reason people look at it and say yes is because they look at it and they go 2 and 4 very quickly, and they're like, oh yeah, we can reduce the 2 and a 4, right? What are they overlooking when they say that? They're overlooking the 1 that's on what element? The S. Remember, you've got an S that has a 1 right there. So can you reduce a 2, a 1, and a 4? No. Okay? So this is already in lowest terms. This one is both the empirical and the molecular formula. Okay? Oftentimes, the ionic compounds are already going to be reduced. When you write them, and you saw that on the test, compounds, there were a couple of them, but were most of the things that you wrote on the test able to be reduced? No. So a lot of the things that we will write will already be empirical formulas. They're not going to be able to be reduced. Sometimes you'll have things that are both empirical and molecular, and that's okay. Okay? Now, we want to learn to get an empirical formula strictly from calculations today. Okay? Everybody got it? All right. So how are we going to do that? Going to do, all right, as soon as I manage to do the screen right. All right. So we're going to do this mathematically today. We're not going to use that oxidation sheet. We're going to do it using math. So the first step is going to be to change percent to grams. A lot of the math calculations we'll get will not give us grams directly. It'll give us percents. So we're going to have to change the percent to grams. Then we're going to have to change grams to moles. Well, that's not an issue because we all know how to change grams to moles. Now, number 3 looks hard, but it's not. It just sounds sort of weird when I tell people what we're going to do. We're going to divide the smallest number of moles by itself and all the other numbers of moles by that same smallest number. What? That's why I said it sounds weird. We're going to divide. Yes, it's sort of like, you know, in math class, if you add 5 to the right, what do you have to do to the left? Add 5. Add 5. So if you divide the smallest number of moles by itself, what do you have to do to all the other numbers of moles? You got to divide it by that smallest number. That's all number 3 is saying. Everybody has to get divided by that smallest number. And then number 4 is the easy one. We write the formula. All right, everybody caught up? All right, so here's the sound. And I'll give you a moment to write it down. Then we're going to see if we can work it. All right, so a couple of you are still copying down the problem. How are we going to change percent to grams? What do you think?
Divide it by 100.
Easier. Easier.
Wait,
I said, how are we going to change percent to grams?
Get rid of the percent sign.
By doing what?
Additive. Erasing it.
Yep.
Oh.
That's it. If we add all 3 of these numbers together, what do we get? 100. 100%, right? So we're just going to assume this is a 100 gram sample. So all we're going to do is take the percent off and write what? We're going to write grams, okay? So we're going to write 32.38 grams and 22.65 grams and 44.99 grams, okay? Because if it's 100%, we're just going to assume it's 100 grams, okay? So that's why I said when Jada said move the decimal and divide by 100, easier than that, Okay? We're literally just going to erase percent and write grams. All right, so step 2, we all know how to do. We're going to change grams to moles. So what do? All right, make a chart. All right, and this is the easy variety because we don't have any compounds. So do we have to add anything up? Nope. Grams goes on the bottom. What goes on the top? What goes beside moles? Yep. Remember what I told you about moles is going to change after we learn to balance, right? Guess what we're going to learn to do Monday? We're going to learn to balance. All right, so we don't have any compounds, so we just have to look on the periodic table and get their what? Their masses. All right, I'm going to use the decimals today. 22.9, 32.07, and 16. Oops, there's my calculator. Now, notice when I divide, am I rounding off to just one number? You want to take it out several decimal places because I have a couple problems. If you round too much, you will get the wrong answer. All right, so we've done step 1 and step 2. I've gotten rid of percents. I've converted to moles. All right, what was step 3? Divide by the smallest. You got to do it for all 3 numbers. It's just like math class. If you divide by 5 on the left, you got to divide by 5 on the right. So which number is the smallest? Okay, so we're going to divide here by 0.702. So we get 1. All right, so if I divide by 0.7062 there, I got to divide here by 0.7062. And I divide here by 0.7062. Now, when I do that, all right, I take 1.413, divide 0.7062, and I get 2.000. Normally, I don't get exactly whole numbers. All right, this one came out to 3.98. I was hoping one of them didn't. All right, so what is 3.98 going to be? Yes, 3.98 is close enough to 4 that is the exact same thing as 4. Okay? Normally, the top was like 1.99, but that one apparently I did well enough with the decimals that it came out to be 2.00. All right, so the last step is to write the formula. So, what element was here? Well, Ms. Wall didn't do a very good job writing the elements down. This was Na, this was S, and that was O because I didn't write them down initially. I just put them in the same order. All right, so typically when you do a problem like this, they put the elements in the order in the question that they go in the formula, so you won't have to figure that out. So this 2 goes with Na. So Na has a subscript of 2. The 1 goes with sulfur, and the 4 goes with, so oxygen has a 4. This is your empirical formula. Questions? Any questions?
We won't have our blue sheets eventually?
Eventually, you will not have your blue sheets. I told you, week 12, day 60. Today's day 20.
So who's not doing it?
I told you I was going to teach you how to find this stuff by day 60. Have a little faith.
I ain't found nothing. There's those what happens.
Have a little faith. I'm good at what I do, people. All right. Write this one down. This one's got a twist to it. I'm all about twisting things for you.
Yeah, why?
Because it's fun. I get paid a lot. So playing with teenagers is part of the job. Right?
Well,
I'm just being honest. Gotta be some perks. Okay, let me take some feelings down. Maybe the new superintendent's worried trees will fall on the building.
I didn't see her right here.
She's been in the building several times, I've been told.
Where?
I don't know. I've never talked to her.
All right, we got it written? All right, so we start with what? What do we do first?
Get rid of the.
All right, so 26.56 grams, and I'll write the elements this time since I didn't do that last time. 35.41 grams of CR and 38.03 grams of O. All right, we're all converted to grams. What do I do next? Okay. Grams to moles, grams to moles, grams to moles. 39.1, 51.9, and 16. Somebody might want to double check. I'm getting old. Huh? All right, if it should make you happy. All right. Once I have our moles, what do we do then? Divide by the smallest. All right, so 0.6809 divide 0.6792, 1.002. 2.376 divide 0.6792. All right, what do we get? Now, in the second one, we got 1.00. That's the same as what? That's the same as 1. What's 3.49? Like halfway. This is 3.5. That's 3.5. Now, when y'all were writing formulas last week, did we write anything K1, CR1, O, 3.5? Are we starting today? Nope. So what are we going to do with that? To what? No. No.
What? Oh, nothing.
Think math class. What would y'all do in math class with a half?
Round it.
How do y'all survive in math class? I ask myself that all the time. I know y'all learn some math skills. Y'all have them. They're just recessed at the moment. Yes, you do. Okay? They're a little dusty. Dust them off. There are some concepts y'all learned in math class that would help you get rid of a half. What would you do to get rid of a half? Not add a half. You're getting warmer. Multiply by what to get rid of a half? What's a half times a half? Clearly. Multiply by something. We'll get rid of a half. Multiply by why? What's multiplying by 2 called? Yes, multiplying by the reciprocal or the starts with an I. Inverse. Okay? What are you, a sophomore?
No, I'm a junior. I had 5 for last year.
I did too.
Yeah. I only got a teacher for a week.
Yeah.
Okay, I'll give you.
Yeah.
That's true.
All
right. So when you have a half, okay, you multiply by the inverse or the reciprocal. So we're going to multiply by 2. You can't round up. You can't round down. You have to multiply by the inverse or the reciprocal to get rid of the half. Okay? So 2 times 1 is 2. 2 times 1 is 2. And I'm going to tell you the same thing I tell my physical science folks, because I've seen more chemistry kids jack this up than I can shake a stick at. Use the calculator if you can't do it. 2 times 3.5 is 7. Okay? Because if you multiply wrong, you lose points. Okay? And I'm always amazed at the number of people who can't multiply that number. So you get 7 there. Now, you're only in an honors class, so you will only get a whole number or a half. So you're either going to get a whole, like a 1, a 2, a 3, a 4, or you're going to get a 0.5. So if you're working this and you get some crazy number like you get 3.7, that should be a signal to you that you did what? Something wrong. You either got a wrong mass, you divided wrong, you got a calculator error of some kind. Because you're either going to get a whole number over here or you're going to get a half. You're not getting any other kind of squirrely numbers. Did everybody hear me say that? Now, if this was an AP class, you could get a 0.25, you could get a 0.33, and you could multiply by a 4 or a 3 to get rid of a quarter or a third. But I'm not going to do that to you. You're only in an honors class. So you'll either get a whole number or a half. Did everybody hear that? Okay. Now, last one like this because it's a little different. This is different than the last one. I told you, I like tricks. I like to twist things. I'm trying to show you my bag of tricks. So on the test, nobody looks at me and goes, you didn't show us one like that. I'm trying to be very transparent. Everybody's seen everything that I have on the test. I don't want to deprive Caroline of her honey. You would be most disappointed if I did that to you, wouldn't you?
I'd get over it by the morning.
You see, I won't make you mad. I need to feel good at least in one class when I give a test. I get beat up enough in 3rd and 4th period. Yeah, I feel good when people get 15 and 21s. 12. Could have stayed home and got those scores. I didn't even have to come in and teach.
That's 15 or 27.
I don't think so.
Oh, okay.
I think a trained monkey could have scored that. I had this ball in the room.
No, it wasn't.
I wanted to do it.
All right. So tell me what's different about this question as you're writing it down.
So you get two elements with the same gram.
Okay. It's already in grams, I heard, and two elements had the same grams. Okay. So what are we going to do then if those two elements have the same grams?
What about two?
Subtracting the total.
All right. So when you look at what you have here, see how it says this 10.15 gram compound contains phosphorus and oxygen. Okay, so it's saying that 10.150 grams is both phosphorus and oxygen. But this is only what? Oxygen. So that 5.717 grams is only oxygen. So in order to do the question, we need the mass of just what? We need just phosphorus. Yes. All right. So we're going to subtract to get the grams of only phosphorus. So somebody tell me what that is. It's 4 point something, 4.3, something maybe. $4.433. All right, so from there, now you're ready to go. So you're going to set up your 4.433 grams of P and your 5.717 grams of O and solve. Okay? So we've done two. You do that. See if you can get it. And then I'll finish it on the board if need be. I need to mark out mine here, but I'm thinking about it. I will forget. It should be absent. Questions? Anybody? Yeah. Yeah. Except it's fine. Yeah. You did? Mm-hmm. Mm-hmm. And move your decimal move by those. Sure. Yeah. You didn't get this problem yet. The answers. Get a calculator. No, my God. We're gonna be a third or fourth period. You fit right in with, I didn't get a calculator.
But I really can't get.
All right, you're not there yet. You're still getting the moles. You're still on step 2. You hadn't even got the moles and divided yet. Yes. Keep going. I'm not doing anything else except glaring at Lewis because he didn't get a calculator. Yes. Yes. That's a 2.5. So yeah, you got 2.49. So that's a 2.5. What you gonna do with that now? Yep.
Not even every day. That's why I wish he did. Oh. Hey.
Did she say she stopped?
Stop drinking
Yeah.
them.
It's not often. Okay. She scaled back.
No, it tastes like garbage.
Don't
start one.
I've had a few.
I don't even know what it's like.
Ew.
I mean, it's
Yeah, exactly. You said it tastes like carbonated soda. I mean, those are gonna be the same car, go for it.
Right.
I thought you said glory.
I was like, oh
That's what just drink coffee.
yeah,
Or tea.
I stopped drinking.
Thai tea.
What'd you get?
If I can.
So you got 1, 2, 4, 5. So now you take, write your formula. You would have P, 1, and O.
Honestly, I want to go somewhere that rains a lot.
So now you take 1 to the 2.5. What do you get when you multiply?
You live in Canada.
Yeah, I did.
Huh? So you got 2.5 when you divide it.
yeah, you better drink what you want.
So you know the formula for P, 1,
Water is built.
O to the 2.5.
I don't like cold water.
All right, did I get to everybody who was having a hard time? Is there anybody I missed? All right, the last thing we're going to do today is a molecular formula. Okay? All right. Molecular formulas is the second part of the lab we're doing. Now, a molecular formula shows the actual number of atoms. And I'm just reviewing what we did at the very start of this, okay? It may or may not be able to be reduced. Okay? It may or may not be able to be reduced. So this goes back to what we did at the very beginning. Some of these may be able to be reduced. So it might be something like what we did before the test, like if you had S2O6, S2O6 can be reduced into what? SO3. So this would be the molecular formula, and this would be the empirical formula. But if you had an ionic compound such as CaF2, can that be reduced? No. So this, again, is both molecular and empirical. Okay? So when we calculate, we're going to get a number that says it's both molecular and empirical. Here. If you hand it to me, I'll give it back to you in class. Now, if it's both molecular and the empirical, you will get a number of 1 when we calculate. Okay? And I'll show you that in a second. When we have this, is the number going to turn out to be a 1? It's not. Okay? So tomorrow in the lab, sometimes you're going to get this. You're going to get a molecular formula and an empirical formula is going to be the same. So when you calculate, you're going to get a 1. And you're going to, some of y'all are going to come up to me and go, Ms. Wall, formulas were the same. Was that possible? And the answer is going to be what? Yeah. Yes. And it's okay. So don't freak out if you get a 1. All right. Is everybody caught up? So how are we going to do this? All right. First of all, we need 2 things. We have to have an empirical formula and we have to have a formula or molar mass. And remember, it has more than that for a name. You can call it a gram formula mass or a molecular mass, but I'm not writing down all those different names we gave it. Okay? So once we have those 2 things, what are we going to do? We're going to take the formula mass, okay, and in parentheses, I'm going to write the given mass. Okay? We're going to take the empirical formulas mass, and in parentheses, I'm going to write here the 1 you add up. And when you divide, you're going to get a whole number. Now, you have to get a whole number. 1, 2, 3, 4, 5, 6. If you get like 0.7, 2.8, 3.4, you did what? Something wrong. It has to be a whole number. because this number is what the formula was reduced by. It was reduced by 1, which tells you they were the same formula. It was reduced by 2, which is the most common answer. Most formulas, if they were reduced by 2. Some of them reduced by 3 or a 4 or a 5 or 6. Okay? Now, we take this whole number and we multiply it through the empirical formula, and we get the molecular formula. Okay? So all we're doing is basically taking two masses, and we're dividing them, and we get a whole number. And then we're going to take the whole number and multiply it by the formula to get the molecular formula.
What is the empirical formula?
That's the one you have to add up.
Like, what do you mean by add?
You know how we found the molar mass? You know, we take the element and get the number of atoms times the mass off the periodic table, take the next element, number of atoms times the mass, and add it up. That. And we're going to do one. It'll come right back to you. Does everybody have the steps? Yes?
No.
Okay, tell me when you got it. Whoever yelled no. Okay. So, and I'll give you a moment to write it down. Because this is a pretty typical question. What's the molecular formula for a compound with a formula mass of 283.889 U and a formula of P2O5? All right, we have it written. What do we do first? We take the mass that's what? Given. All right? So take the mass that's given. So what's the mass that's given? So 283.889. We have to divide it by the empirical formula's mass, the one we add up. What's the only thing we have that we can add up? The P2O5, right? So we're going to take P2O5 and we're going to add it up. So how many P's do I have? How many O's do I have? All right, what's the mass of P? I'm going to use whole numbers to make my life easier. 31, 16, that'll be 62, that'll be 80, 142. That's why I like whole numbers. I can do the math in my head. Okay? So, where am I putting that mass I added up? On the bottom. Now, when I divide that, what kind of number did we say we had to get? A whole number. Now, it might be something like 0.99, but that's going to round to a whole number. So when we divide that, since Chris is calculating it for me, what do I get? 1.99? All right, 1.99 is the same as what? That's 2. And like I told you, that's the most common answer to get. This means, what this means is the formula was reduced by a 2 originally. Because what we're doing is we're figuring out what the original formula was. So the formula was originally reduced by 2. Okay, that's what you just figured out. So the last step is to take this whole number and multiply it through the formula. Okay, so we're going to take the 2 and we're going to multiply it by P2O5. So what is the original formula? What's the molecular formula? P4O10. This is our answer. Now, let me caution you. This is usually where 1 or 2 people run off the rails. And they look at that answer, and what do you think they want to do to it? If you reduce the answer, what'd you just do? Exactly. You just wiped out all of your work. Okay? You can't reduce your answer in this question because this question is asking you to go back to what it used to be. Okay? Does that make sense? I'm just telling you what happens. They're just pitfalls. It happens all the time. It just happens. So I'm trying to keep y'all from doing that. All right. Y'all do this one real quick. And then we need to talk about homework since we get out of here at 9:40. Go to Club Day.
Are we gonna have to do anything online, like you said?
The only thing I would say is you're going to have to be able to combine these two, and we haven't done one where we combine the two. So if you want to see one that's combined, I can post it and tell you how far fast forward through the video, so you can see one where we've done it combined for tomorrow.
Can you do that?
I can find that and put it up there. Yep, that's the only thing we haven't done, and we would have gotten to that if we didn't have Club Day.
The SIT team and DMT will meet in the guidance conference room during Club Day.
Got an answer for me? What'd you get? All right, I hear C6H6. Everybody agree with that? You should. It's the right answer. C6H6. I'll work it in just a second. Maybe they didn't write the question. So you get 13, 13, 6.
Students, the bell will ring for Club Day shortly. Please check the lists that are posted in the blue hall at the top if you do not know your club by now. Also, Ms. Hathaway, please report to the front.
All right, C6H6. All right, on this, on the front side, the one that says empirical formulas, I want to do 1, 3, and 5. All right, on the front, 1, 3, and 5. On the back, I want to do 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. Now, the reason for the larger number is tomorrow on the lab sheet, you get a partner. You do not get your notes. Everybody hear me say it. You get a partner, no notes. Okay? All All right. Hope you enjoy clubs today.
What do you got?
It does the-
Oh, leadership?